An imaginary study involving 650 people was conducted to assess the performance of the stool antigen assay in detecting a Helicobacter pylori infection. After collecting all the test results, it was found that 250 people tested positive and 400 people tested negative. Question 1. If the positive and negative predictive values were 80% and 75% respectively, then what proportion of people with the disease were identified by the test?
To help us answer this question, we are going to enter the data provided into a sample table. In this cohort, there are 650 people in total. The total number of positive tests is given to us in the stem of the question. There are 250. We are also told that there are 400 negative tests. The number of people with an infection who tested positive can be calculated by multiplying the number of people with a positive test, 250, by the positive predictive value, 80%. To calculate the number of false positives, simply subtract the total number of positive tests, 250, by the number of true positives, 200. The number of people without the infection that tested negative can be calculated by multiplying the total number of negative tests, 400, by the negative predictive value, 75%. To calculate the number of false negatives, subtract the total number of negative tests, 400, by the number of true negatives, 300. The total number of people with the disease is calculated by adding together the number of true positives, 200, to the number of false negatives, 100. The number of people without the disease is calculated by adding together the number of false positives, 50, to the number of true negatives, 300. Now let's go back to our question. 300 over 650 is the prevalence of H. pylori infection in this cohort, so A is wrong. 200 over 250 is the positive predictive value, B is wrong. 200 over 650 is the proportion of true positives in this entire cohort. The correct answer is thus C, the proportion of people with the infection who tested positive, that is the true positive rate, which is the sensitivity of the test, is 200 over 300.
Question 2. How would the sensitivity of the test change if the number of positive tests was higher?
While increasing the number of true positives in relation to the number of false positives would increase the sensitivity, increasing the number of false positives by itself would not affect the sensitivity whatsoever. An increase in the number of positive tests in any combination could by no means decrease the sensitivity. The sensitivity only takes into consideration people that have the condition, and thus it is completely independent of the prevalence. Since we do not know whether the positive tests were true or false, there is not enough information to determine whether or not there would be a change in sensitivity.
Question 3. What would the sensitivity of the test be if 10 people with the condition did not test negative?
If 10 people with the infection did not test negative, there would still be 300 people with the infection. Thus, A and C are wrong. Since there would be 10 less false negatives, the number of true positives would increase to 210. Thus, D is wrong and the correct answer is B.